Welcome back to more Space Engineers Programming with your host, Pilot Error 42. Today, we are going to talk about state machines. What is a state machine? A state machine is a way of directing your program flow so that you can split up what your program does based on its current state, its current situation. That's a very general way of saying it. So, let's get started. We have our blank editor. So as always, oh, well that's new. Can we? Oh, that's nice. Okay. I'm not sure if you can see this or not, but the cursor is completely messed up. It looks like it's just that first line. Okay. Sorry about that. The cursor's completely messed up. So, as always, we start off with our void main, which is the main function. So, how does the state machine work? Well, generally, in your main, you use something called a switch on your state. And we're going to set up our states in a minute, but until then, a switch is a way of basically, based on what that value is, it will put it to different places. You set that up by using a case, and then either a value or a lot of times you use constants and whatnot. In this case, we have a constant called initial. And we have three cases: initial, light on, oops, and HT, light off. Ooh, that needs to be lowercase. Okay. So, what are these? Ideally, we would have a nice enumerator. We would call it public. I mean, the public. Actually, we don't need the public on it, because we're the only ones who are using it. States. We would have something like initial, light on, light off, and those are our three states in the state machine. And we set up by doing something like state current state dot initial, and that would give us a current state dot initial. Unfortunately, Keen Software has decided to completely hack apart the like the underlying C# language. So switches don't work on enumerators. You get some stupid error. They also apparently don't work on integers. I haven't tested that, but that's what I see in the programming forums. Apparently, they only work on string constants. Yeah, which normally you can't use a switch statement on a string at all. In most languages, that's just something you can't do. However, that's what we have to work with. So we're going to. That's why I have the initial light on and light off as all caps. So initial equals, and the actual value I choose doesn't matter. As long as they're distinct from each other, it doesn't matter. But for the sake of readability, we're going to say initial is initial, light on, etc. So now we have our string current state, and then when you first load this, the first time you run this program, and any other times after it's been loaded from a save game, it's just gonna default to initial. Okay? So, what are we gonna do during initial? We're going to call our init and set the next case. So set the next state. Light on. And then if you don't say break, it will continue just running top to bottom. If you want it to go back up to the switch, you could actually say continue, and it'll just jump back up there and reevaluate the switch. Which actually, you know what? We will do that for the initial case. That way, once we have init, we'll do the stuff for when the light is on. Okay? So if the light is on, what are we going to do? We're going to do the light on work, and obviously with all of the last video and this one and probably the next one, the whole turning the light on and off, those are just examples of work that we can do. It's pretty useless to blink a light on and off. I mean, unless you want the light to blink at random intervals, in which case, here you go. So that after we do the work, we increment to the next state, and this time we're going to break. That way we're not going to get called again until the timer block, this guy up there, timer block calls us again. So what do we do if the light's off? We do lights off work, and we increment our current state to light on. Notice we're never going to get back into initial. The only values for current state are going to be light on and light off. It's just going to go back and forth between the two, and that's what we want. And then break. If you don't put that break there, it'll go back up to the top and evaluate the switch again. Okay. So then what do we do after this in our main? Well, we grab our timer block dot apply action. We start we start our timer block. Now we haven't declared our timer block yet, so let's do that. I want this line. I want that line. The editor has bugs in it. So what global variables do we need? We need our interior light. We're just gonna call that one light. Oops. And timer block. And just like with the other stuff we've been doing, we're also going to be using the random number generator. So now all we have to do in order to complete this is do our init and do our two works. Obviously you can have more than 3 states, and you can do a conditional increment to the next state, which you would probably do not in the switch statement, but within the work packet that you're doing. And I highly recommend apply. I highly recommend doing it like this, where you have a function for each state, or a couple functions for each state if 2 of them share the same and whatnot. Instead of, because you could do all your work underneath the case and then break, but that makes it difficult to follow and to go back into and find where you are, because you tend to, these things can get real long real fast. So there's a couple of empty lines underneath it. So here is our init. So we're actually going to, we can do something like this. Light equals null. Light equals grid turbo system dot get block with name. And this is just what I've named it. State machines light, but we want that as an my interior light. We can do something like that. This should be tabbed in. We can do something like this where we only do it if light equals null. However, we don't actually need to do that because we're only getting called in that initial case. So we actually just get rid of that guy, and this should just be a single tab, which actually also allows us plenty of space in the editor for the as to go on the same line. So we set the light, timer block. We can do the same thing for the timer block, grid terminal system dot get block with name. And then, whoops, accidentally hit enter. Where that one is named state machine timer block. We need that as an my timer block. And then initially we're going to turn the light on. And we do that by using the action on off underscore on. There is an action that's just on off, and that will toggle it. And I'm just gonna throw this down here since we're doing something different. And we also want to make sure that the timer block's delay is the smallest we're allowed to have it, which is 1.0, which is unfortunately you're only allowed to run these programs once per second. There are ways around that. You can have it so that the timer block runs the program and then performs its own action and then starts itself, and then in the program you can also trigger the timer block to start to perform its action. So you can actually get it. I think in the forums they're talking about maybe like up to 5 times a second, but the timer block stops responding after a bit. The program will still run, but none of the lights look right, and it doesn't update its status in the control panel. And I wouldn't be surprised if they patch that in the future, because they really do. They don't want these scripts to bog down a server and just utterly destroy it because it's doing too much. That's why they have this limitation, because it's doing too much, or if it's just being run too frequently. So we're going to follow the rules, and this, because we're setting value float, this defaults to a double. So I'll stick an F there to tell it, hey, that's a float. So that is all we need for our init. Well, now that's all we need for our init. What other functions do we have? We have the 2 work packets. So void light on work and void light off work. Okay. So we're going to do our work for light on. I know it's all caps up there, but I am using camel caps because I like it. So to our light, we're going to apply action on off. Off. So when the light's on, we're going to turn it off. And then to our timer block, we're going to float. We're going to set the trigger delay to be a random number. Now, you may be wondering why every time I do set value float, I tend to do that and then go back. That is because there is no code assist. We just have a plain old text editor. So in order to make sure that all of the parentheses are lining up, I tend to just bloop. And same thing with, I tend to do two quotes and then go back. I also usually do that with the brackets. Before I put anything in it, I make sure that I close the bracket and set the proper indentation. Sometimes I forget, obviously. So in here, we have our trigger delay. And we're going to use our random number generator. rng. Next, we're going to get the next integer between 10 and 50. But then, because we want it, I want it to be able to not just trigger on the seconds, but between the seconds. So this way, if we divide it by 10.0 float, that'll give us a number between 1 and 5. So every 1 and 5 seconds, it's going to move on to the next state and handle the light off. But we can also do it at 1.1, 1.2, 1.3, etc., etc. Not just 1 second, 2 seconds, and 3 seconds, and so forth. So that's what we're going to do here. And actually, for the light off, in this case, normally you would probably have it actually do something different. But in this case, we are going to change that. All it's going to do for our light off work is turn the light on and then set our delay in our timer block. So this will, just like before, just like with the other delays, it will flash the light on and off random. Let's make sure no closing loop out of which to break or continue. It doesn't like this. I'm not sure if that's a that I don't think that C# is going to be any different in that respect than most of the other languages. It may just be something Keen has done to it, but apparently you're not allowed to do continue to go back up to the switch statement. Or I may be completely wrong and you just can't do that in most languages. Either way, looks like we have to break out of that. So let's go back in here. What are we doing? We're setting our state, and then we're handling our state to be either initial, light on, or light off. We're doing a work packet for the appropriate thing, and changing our state. Sometimes you might not want to change your state, depending on what all you're doing. If, for example, you're not done, but you can't do it right now, and you want to wait for a little bit. For example, if you were making an automatic docking procedure, you're going to want to keep every second checking to see if your connector can connect. If it can, then you're going to connect it and move on to your next state of connector is connected. If you can't connect, then you're probably going to want to stay in your check connector for connection state. There's no rule saying you actually have to move from one state to another in a predictable pattern. It's just however the logic of your code dictates. So I'm going to remember an exit. I'm going to run it. And we'll look at that. It's a flashing light. So that is a basic state machine. There's a few different ways that you can implement it. This is probably a relatively simple way. I know that I've seen really nice state machines in other languages where there's state validation that when you try to move from one state to another, you can only do so if you're allowed to, if you're coming from the correct state, and if various properties are fulfilled and whatnot. But hopefully your logic is going to be sound, and you're probably not going to be doing anything that complicated that you need that sort of validation. After all, we really do only have one thread in this, so you don't really have to worry about a lot of the stuff that can make it more complicated. So here we have our blinking lights, and a little preview for next time. And we're going to be right over here, and that is going to cover timed actions that you do at a specific time, or time offset from now. So, as always, this has been Pilot Error 42. It's been a pleasure having you, and until next time, see ya!